So thank you everyone for coming to this session. So I am Imre. I'm a Google developer expert from Indonesia actually, but I'm now living in US. And I've been GDE since 2019, and I'm especially in cloud expertise. So if you want to follow me on Twitter, I'm on Imre Nagi, and I also have YouTube, but it's most of the content are in Indonesia. But yeah, today anyway, we are going to talk about how we're gonna do development in cloud. So we're gonna discuss about two technology that came from Google. The first one is Cloud Workstation, something that recently announced by Google in Google Cloud Next this year, and the next one is open source project by Google named Skaffold. So we will see in the end how those two technology can work together in order to help us in doing cloud development. So yeah, I think this is the typical development workflow that we have. So there are two stages, right? The first one is local development, and the second is actually CI/CD automation. So during the local development, what we do actually, we start work by implementing the features, and then we run the automated tests here. And after that, we build the application, and then we test the app locally. Uh, Once we are done with one, we typically go back to the initial stages, which is implementing feature until we are done, and then we test it. And once it is ready and we want to deploy it to staging, we push the code to Git, and after that, CI/CD automation will be triggered. And what happened here is that during the CI/CD process, there will be automated test running, and it will also build Docker images because in this context, we want to deploy the application to Kubernetes. So we need to prepare Docker image first. And after that, once we have the image ready, we're going to deploy the application to Kubernetes itself. And there are some challenges if we are doing this kind of development. So there are three categories that I have prepared here. The first one is about development environment setup. So in case we have a complex setup for the application, let's say your company has microservices. So if you want to onboard new team member, it will take time because the new joiner will have to set up their own computer, install everything, sorry, install dependencies and on. And then there are many things that they have to do. So in this situation, they probably will be start coding after 2 or 3 weeks. Because there are so many things that need to set up. There are so many things that they have to prepare before start working. And also, if you want them to have something like a powerful machine, you're gonna have to provide them with a high-end dev machine. Typically, company will have you provide with a 16 gigabyte of RAM, and then it costs you a lot. So, cost of providing this high-end machine is actually can build up in the future if you have so many developer, and this is not good from the cost perspective. And then if we are talking about how we develop the application, right, locally. So when we are developing our application locally, it's actually not the same as the production environment that we gonna have. So let's say you are working on microservice app. Your app will run on Kubernetes. There will be multiple machine in Kubernetes, but you only have one machine locally. And then if you have several dependencies like microservices, other microservices that you depend on, it's gonna hard to replicate that on your machine because you're gonna have to run everything. And then, but again, you are not running on the same thing. You're not running it as a container or even a pod. So that's gonna be challenges in development environment setup. And then the next thing, if we talk about developer productivity, right? Uh, when we are working in, let's say, microservice setup, there are so many dependencies that we need, like databases, Redis, cache in the cloud, and also other services that probably reside in cloud. But all of the resources probably are protected inside the private network. So let's say you have your own computer, you need to connect to VPN so that you can talk to the resources in your private network or VPC, and then it gonna takes time, and sometimes the VPN connection is not stable. So VPN again, and then you continue development, and then sometimes the VPN get broken again, and then you have to redo everything. You have to reconnect and so on and so forth, and then it takes time. So in terms of productivity, it will slow you down because you need to worry about how the VPN connection will work, whether it's gonna be stable or not, and then there are many things. But you need the dependencies. But if you install the dependencies, all of them in your computer, your machine will probably not enough to run all of them because probably there are so many things, so many services, so many database. And then it's also hard to get enough feedback about changes. So let's say you implement a feature, and after that, when you want to test that on the cloud, you're gonna have to execute the CI/CD pipeline. And CI/CD pipeline typically takes time because it has to run unit tests. Probably unit tests will take you 10 to 20 minutes if there are so many tests, automated tests like integration tests and so on. And once you figure out, gonna have to redeploy again, and then it will take another 20 minutes or 30 minutes. And then it means that the development cycle will be quite long. So you cannot get faster feedback if you are doing development like the image that I illustrate before. And it is also hard to debug the issue because you cannot do something like live debugger, something that provided by the IDE. So you cannot set breakpoint, you cannot run step into, step over, and so on. You cannot use that kind of thing. So it's gonna be hard for you to debug the problem unless you create log. So what we typically do, we do console log, and then we see on the server log whether there is log printed or not. And that's how we typically do debugging in cloud. And it's also not helping you in terms of developer productivity. And the last thing that I would like to mention is about security itself. So imagine that when you provide somebody with computer and then they have to pull the application to their local, happen with their computer. Some of them will get robbed. The computer will be stolen, and then there are so many important things, important documents, and probably important code on that laptop, and we cannot risk that. And yeah, basically, if you have source code get pulled to your computer, basically you have no control over that source code anymore because it will be responsibility of the computer owner to protect that source code. So those are the challenges that we typically face during the development. And then if you're talking about one solution that announced by Google recently, like it is called Software Delivery Shield. So it is end-to-end software supply chain security solution provided by Google. So it discusses about how we're gonna do development, how we're gonna do software supply chain in terms of dependencies, whether you're using library, how secure the library that you're using are, and so on. And it also talks about how you should do CI/CD, how you can secure your CI/CD pipeline, and also when you run the application itself on the cloud, probably in Kubernetes, in VM, and so on. So this software delivery shield are talking about all of those things. But today we will focus on how we're gonna do secure development by using Workstation and Skaffold. Those are the technologies that involve in the security shield solution. There are cloud workstation and cloud code. Those are something that we're gonna discuss today. But if you see here, there are also Google Cloud Build, Google Cloud Deploy, Kubernetes, Cloud Run, and binary authorization. But unfortunately, we cannot discuss all of them. So we will focus on those two technologies, which are cloud workstations and cloud code. So what is a cloud workstation? So it's actually help you to create a consistent environment on demand basis. So let's say you want to provide a computer for your team member in company, you can just create a workstation for them, and then all of the things that you need can be set up on that workstation. So the new joiner, when they are joining your company, they don't have to do setup at all in the beginning. Probably they will do some setup, but it will not as many as if you just give them a laptop, because you can prepare how workstation will look like. We're gonna go into that detail later, but as you can see here, it's a fully customized tool chain. So actually, when you create a workstation, you can have an IDE running on cloud. As you can see here, this is a VS Code that is running in a browser. So this is a IP address. No, this is the DNS of the workstation itself. And then when you run a workstation, actually it is residing in Google VPC, Google Cloud VPC. So you can decide where you want to deploy your workstation or the computer that you are managing in cloud, and then you can put it in a particular VPC and other VPC if the developer need to connect with other VPC or other resources in the VPC. And it also has some security features like you can use SSH tunneling, secure tunneling. It's also provide you with the TLS in the browser and so on. And the most important thing for the user is actually this one. So you can provide the customized development environment with custom-based image. So let's say you want to provide an Android developer. So you're gonna have to install Java on their computer, right? So you can set up the development environment by setting up Java in advance. So when they spawn a workstation, they will have Java already installed, or probably something like Android Studio. So if you have data scientist team, you can also configure a computer for them that has Python installed and probably some other features required for data scientists. And then, yeah, as you can see here, the workstation is running in browser right now. You can access it via browser. We will go into this. But if we talk about how we're gonna configure the workstation, right? So these are several terms that you need to be aware of about workstation. The first one is the cluster. Cluster in this case is just the grouping. So let's say you have a data science team. Data science team probably develops several applications. The first one is Java. The second is Python. And another one is probably using Go or any other languages. And then what you can provide here is that you can provide several configuration. The first configuration here is using IntelliJ. So you can define the editor or IDE will be IntelliJ. And then you can define the machine spec for this configuration and also the permission for this config, who can create workstation from this config and so on. And for the second config, you can also define what the IDE that will be using, what are the machine specs, and who can have access to this configuration, and so on and so forth. You can any configuration as you want. And from this configuration, there will be a term called workstation. So workstation is like a VM. So if you have the template, which is the configuration, you can create a VM from this configuration. So in this case, I will create the workstation one. Let's say it will be assigned to me. I will be the owner of this workstation. I will be owner of this Linux machine. And there will be the second workstation, which has IntelliJ. It will be assigned to my colleague and so on. And all of this workstation can be used directly if the configuration has prepared everything. We're going to go into that later. If we take a look a bit about how cloud workstation architecture, right? In this case, cloud workstation, as you can see here, it is running inside a VPC network. So when you define cluster, you can also define which VPC that it will deploy to. And then once you create a workstation, it is actually a container running on a VM, running on a compute engine. And there will be several things that is provided by Google in order to secure your workstation. And if you can see here, you can also create a persistent disk for the VM. So it's like you can define how many gigabytes of disk that you want to provide for every VM. You can also do something like that. And this persistent disk will be kept as long as the workstation running. So we will go into that later. I will show you in the demonstration. So yeah, let's go to the demo. I know slide sometimes is a bit boring. So let's go to this one. So this is the cluster that I have mentioned. So this is Cloud Workstation. If you go to the Google Cloud Console, right? You can see that there is a config cluster here. So you can create a cluster, but I already create one. So in this case, I have this cluster name, and then I decide the location is US Central 1. The VPC will be default VPC, and subnet will be default subnet. And then once I have the cluster, I can create as many configuration as I want. In this case, I only create one. So let's take a look into this. So I have prepared a configuration. In this case, I define the instance size for E2 standard 2 CPU and 8 GB of memory. So when somebody create a workstation by using this configuration, they will get this specification for the machine. You can change it. There are several options available, but I believe it's not as many as the option that you will see when you're creating a VM. But yeah, I think because this product is still in preview, so I think that's good to have several type of machine here. And then if we take a look into environment customization, you can also provide the container image that you will use to create the Linux VM. So you can use the default images that is provided by Workstation, but you can also provide your container image or Docker image here. You can create several configuration. You can see how to extend the configuration on Google Cloud documentation. And you can also specify the size of the storage. And also there are several advanced configuration that you can set. The first one is the command of the container itself. When it run, what command that it will execute, what argument that will be passed into the entry point. And the most important thing probably for your own local development is environment variable. You can also define environment variable that you want for this VM. So when the workstation ready, the developer doesn't have to look for the value of environment variable, because I believe that it will be a problem of every new joiner when they need to figure out what is the value of the environment variable, because some value might not be provided in the Git because probably it is a secret. So they cannot really write it in Git and push it and commit. So this is one way if you want to provide secret to the workstation itself. And yeah, so when you're done, you can save and then it will create a configuration. And from the configuration, you can create a workstation here. So my workstation has been stopped, so I will just start it. And then we're gonna have to wait. But if you want to see here, the workstation, when you create a workstation, you're gonna need to specify the configuration. So the configuration here is the configuration that I just showed you. But now uh, I'm just starting this workstation again. So it will take a couple minutes. So probably we will get back later when we are done with the workstation provisioning. But what we will expect from this provisioning is that when the workstation is ready, you can directly use it to start coding. So you don't need to install any dependencies at all. You probably need to authenticate your G-Cloud account so that you can have proper access when you are doing development. But most of the dependencies that you can think of can be prepared before you start using this instance. So let's go back to this one later. I will show you how we can see this dashboard later, this browser. Yeah, I think it will take time. Instead of waiting until this finish, let's continue for now. So yeah, I think that's about workstation. If we go back to the slide, when we have the workstation, right, there are several problems that have been solved. So the problem related to the onboarding is done. So you don't need to you onboarding time will not take as long as what you typically has. Probably it will get shorter, and the cost of providing high-end dev machine will no longer exist because you can spawn a workstation and provide your employee or the developer with a lower end dev machine, because they don't need high-end machine anymore because everything will just be running in the cloud. But this problem will not be solved because actually when you're running the workstation itself, right? So it's still a VM. So when you run your application in Kubernetes, in a container, so the environment will not be the same, exactly the same. It's still a VM, it's still a computer anyway, so it doesn't mimic the real production setup. So this one doesn't solve yet. It's not solved yet. And about developer productivity, the problem related to working with resources in private network has been workstation now is already on the private network itself. So it's already in VPC. If you want to connect it with other VPC, you can create a VPC peering or something like VPN tunnel. But you still have to push the application to Git so that the CI/CD pipeline gets triggered. Thus, the problem still persists here. So it's hard to get enough feedback in time manner. The CI/CD takes time, and also hard to debug the issue because you cannot really use the breakpoint as I mentioned earlier. But related to the security, all of the problem that I mentioned earlier actually has been solved. Why? Because when you already provision a workstation, when there is no possibility of let's say the computer gets stolen, right? And then you can just revoke the access to Google Cloud account for the developer, and then the thief will not be able to access the machine anymore because the access has been revoked. And there is no source code on their local anymore because the on the cloud, on the workstation itself. But what we can do in order to solve the remaining problems. So it is actually easy. If we go back to the initial workflow that we have, we probably need to do a slightly modification. Uh, instead of running the application locally, why don't we run it directly in Kubernetes during the local development? So you implement feature, you run automated tests, and after that, you run and debug your application in Kubernetes directly. So you do deployment directly from your local to Kubernetes before you trigger the CI/CD automation. So once you are done here, you will commit your code, and then it will trigger the real deployment to staging and eventually to production. But how we should do this? What is the best way for doing this kind of thing? Because you still have to build the image, you're gonna have to deploy, and then you're gonna have to tail the logs. This is probably the naive solution that we can. Once you are done with development and you want to deploy to Kubernetes, you build the Docker image, right? And once you build a Docker image, you push the image to a container registry. In this case, it is a Docker Hub. And after that, because we are deploying to Kubernetes, so we must have the Kubernetes manifest. In this case, deployment YAML, which contains the deployment manifest itself and the service manifest itself. And then once we apply this, we will do port forward so that we can test it locally. And once we port forward, we probably want to see the log. So we run kubectl log minf deploy book API so that we can tail the log and see what log will be printed if we run a particular command or hit particular API. So this is a naive solution, right? But there are still problems remain. The first one is live debugging is almost and not even when you have done these things, you still cannot use debugging feature provided by the IDE, like breakpoint, step over, step into, and so on. And then when you run this command multiple times, and Docker build and Docker push, you will end up with so many things in your container registry, Docker image registry, because you keep pushing different images for local development to your container registry. But this image will not be used even for staging and production, because when we want to deploy to staging, there will be different image get created. And the last problems is about the waste of resources used for deployment. So let's say you are deploying deployment here, right? So let's say you are deploying a pod, and then once you are done with local deployment, you forget to clean it up. And somebody from your team is also running the same command, and it will get different pod in Kubernetes. And then tomorrow when you get back to office and then you run the same command again, it will probably create different deployment, and then it will end up consuming your resources, consuming CPU, memory, and it will cost you much if you don't clean it up. And that's why there is another technology that I want to introduce, which is Skaffold. Skaffold is actually an open source software that is created from Google, but it has been out probably for several years. And main focus of this Skaffold is actually how we can optimize the source to Kubernetes deployment. What does it mean? So when you have your code, right, and then when you do some changes, how the changes can directly be deployed to Kubernetes in timely manner. Instead of executing this command over and over again, probably there will be several issues when you running this. What is the best way to do that? The answer is by using Skaffold. And how Skaffold will help you when you do a cloud development. So it will help you it will help you by providing some capabilities provided by Kubernetes like port forward and log. So when you run your deployment in Kubernetes, you can still test it like when you running them locally. So you can port forward. So you just need to curl with localhost 8080, and then everything will be the same because there will be connectivity created from your computer to Kubernetes. And then the good thing is that you can also see the logs automatically. So you don't have to run kubectl logs anymore. Skaffold will handle it for you. And then Skaffold will also help you in doing live debugging, but unfortunately, I'm not able to demonstrate it today because several issues that I've for this presentation. But if you go to Skaffold documentation, you will be able to see the step in order to debug your application live in Kubernetes. And how to configure the Skaffold is by using a YAML file. So this is the example of YAML file. I'm going to go to this configuration later on. But the thing that you need to know is that if the build configuration and also deployment configuration can be configured from this file. So in this case, we'll do deployment by using Helm. So I can have this kind of configuration. And let's say I want to have this image for development. I can also specify the config. And I can also specify whether I want to build the image in cloud as well, or whether I just want to build the image locally. So I can configure several options here. There are so many configuration that you can find in the documentation, so feel free to explore it. And then it is lightweight, so it means that it is client side only, so there is no server that you have to run on Kubernetes itself. So it's not like Helm 2. So it's more like Helm 3, because Helm 3 is just a client side. So you don't need server side anymore in Kubernetes. And then the most important thing is that it has integration with common IDE for developers. So it has IDE integration under Cloud Code extension for VS Code, and also JetBrains IDE like IntelliJ, Golang, and so on. So yeah, how does it work? So when I say earlier that it will deploy your changes directly to Kubernetes, right? So what happened is that when you run Skaffold command, it will detect code changes from your local. It has something like file synchronizer, which will check the code changes, and once it observes changes, or if you trigger it manually, it will start the pipeline. The pipeline will consist of building the artifact, building the Docker image, testing the artifact if you configure it, and it will also tag the artifact with several kind of format, and then it will render the manifest. If you want to deploy to Kubernetes, you're going to have to provide the manifest, whether you are going to use native Kubernetes manifest, or you are going to use templating engine like Customize or Helm and so on. It will basically render everything for you. And once it is rendered, the application will be deployed to Kubernetes. And once the application is running, the most interesting thing is that it will tail the log and do port forward automatically. Okay, so at this point, you can start calling your application, and then you can check whether the log print something that you expect or not. And once you are done, actually it will clean up images and resources in Kubernetes. So everything will be cleaned up. So you left nothing in your Kubernetes cluster, or probably in your local computer. So everything will be cleaned up. So this is just the extension from the previous image. For building, there are several tools like Dockerfile, Bazel, and many other tools. And for deploying the artifact, there are also kubectl, Helm, and Customize. So I'm gonna demonstrate it after this. Yeah. So let's go to Workstation. We already have the Workstation running, right? So the one thing that we're gonna do is that we're gonna launch it. What happened here is that you can connect to your Git repository. I can, because, okay, let me log in again. I will continue to GitHub and my authentication. Give me a sec. Oops. Okay, so once I connect my workstation with GitHub, so actually I will be able to search for all of the repo that I own in my local, in my GitHub account. So I will probably pull Cloud Run Hackathon. So this one, this repository, I can just click it, and then it will pull the code automatically to the workstation. So as you can see here, we are currently in a browser, and this browser is actually accessing this particular DNS. This is the DNS that is created for our workstation. So the workstation LAM4QVR5. So you can see this is the DNS for the workstation that we are using right now. And I already have code cloned into this workstation. This is pretty much the same like your VS Code when you're running it locally, but the difference is that it is running now in the cloud. So if I check here, host name, So it will say different host name with my computer. I'll show you so that you don't think I'm cheating right now. So if I'm running host name, so my local computer host name is Imre Nagi, and this workstation is actually running in the cloud. And because I already pull everything, the code that I need, it's everything. This is everything that we need. And then, uh, so basically you can, let's see here. So you can start coding, you can change anything, you can use something like IntelliSense to do autocomplete and so on. But I think you still need to wait. Let me see what you install recommendation extension. So yeah, we can install extension. So as you can see here, I can install the Go extension. If I want to install different extension as well, like Python, you can also search it here. And then, yeah, you can also install many things. So it's like a VS Code running in your computer, right? So there is no difference. And then there are several features like search is exactly the same because the cloud workstation that I'm using right now is actually using VS Code as the IDE that will be installed. So that's the good thing. Because Google already provide you with the base image for the VS Code itself, so you can add more things into the Docker image. You can install Python, you can install Go, and you can install everything that you need for your application. And then here, yeah, that's pretty much about the workstation. So I don't know whether we are able to see. Yeah. So if we see now, there will be a disk attached, which has 200 gigabytes of storage, and then we only use about 1 gigabyte, and then we still have many available disk space. So yeah, this is actually persistent disk created for the workstation itself. So yeah, I think that's pretty much about the workstation, right? And now let's talk about how we're gonna do deployment to Kubernetes from local. Because if previously I told you that we can do something like Docker build, right? Docker build mean t imrenagi slash run latest, something like this. I can run this. I can build the image locally. I can push it to uh, my Docker Hub, and I can also deploy it directly from here. But that's not something that we want to do now. We will use Skaffold. If you see here, I already have a configuration for Skaffold. The name is Waterfly, and then I have two profile. So when you're deploying with Skaffold, you can tell which profile that you want to use. I have two now. The first one is Helm. So I already prepare all of the things related to the Helm template and then Helm values and so on. And I also have something like Kubernetes profile. So this Kubernetes profile is actually using raw Kubernetes manifest. Let's go into the raw Kubernetes manifest first. I have deployment, I have Kubernetes here, and I have deployment YAML. So these are the manifest that I will deploy. The first one is the service itself. It opens port 8080 HTTP, and then it has one deployment with several configuration like log port 8080 and the CPU limit, CPU and memory resources that is required to running the application. So I define everything here. So I can use this if I want to deploy the application by using Kubernetes. But if I want to use Helm, I can also provide several options like the chart that I want to use to deploy. So I have provided as well. So there is a Helm directory here. There is a template, deployment, and service. So actually, the manifest that you are seeing in this Kubernetes directory is actually something that is generated by Helm. So I just create it and then put it in different directory. So when we deploy by using Helm or Kubernetes, actually the manifest will be the same. But here I can still provide two different way to deploy my application to Kubernetes. And let's do the deployment. So what we're gonna do now is that I'm gonna open the Cloud Code extension that I told you earlier, and I will just press this run button. So if you see here, it will start initializing the session. It will running a command, which is scaffold dev. So you can use the CLI if you want, but if you want to have some convenience, you can just use Cloud Code. Cloud Code is actually built on top of the scaffold CLI. So you can use Cloud Code and then just click play button here, and then it will run scaffold dev command, which will build the image and then do deployment and then tail the log and do port forward. So we're gonna see it in action. So it's currently building the container itself. So I believe because we are using Helm profile, let me check. Yeah, the profile is Helm. Like here, it will build the image locally. Oh, okay. What's wrong? Docker build run into internal error. So let me try again. If not, we're gonna have to change something. So bear with me. I hope everything will run as expected. Yeah, so if you have questions, feel free to leave the questions on the chat so that we can check it later. So let's try once again. So now it's building the image, and what we should expect that once we are done with the deployment, once we are done with the image build, we will deploy the application to Kubernetes. I don't know, it's not running yet. Let me see. Okay, Docker build run into internal error. Okay, I don't know what's wrong. So let's try again. Let me change instead of using uh, this, right? Instead of using local, let's use Google Cloud Build. Okay. I will just change the configuration now and redeploy. So what I will expect is that instead of building the image locally, I will build it in Google Cloud Build. Let's see. Okay, so looks like it is working. So it will build the image. So if we want to take a look to the uh, Google Cloud Build itself, so we can go to here, Cloud Build, dashboard. There should be a pipeline running right now. History. Wait, it should be in global. Yeah, so there is something running. So it's actually building the image. So let's go back to the workstation itself. So it's currently building the image. So yeah, in case you find difficulties building your image locally because probably your memory is not enough and so on, you can still build the image in the cloud as well. So uh, actually there is no extensive operation running on your local actually right now. Uh, we delegate everything to Google Cloud, but unfortunately, oh, did we change something in the code? Ah, yeah, this is the issue. Okay, so let's try again. No worries, we still have time. So, is there any question so far? Question that we probably can start answer. No. Okay. Let me know if there is any questions because now I cannot open the chat, so I cannot really check. So yeah, let's see. So we are building the container again. Once again, bear with me. It should work. So yeah, so we are building the image in container registry. Sorry, in Google Cloud Build. So you can see here that there is error as well. If we take a look into this log, we should be able to see the issue. Yeah, so you can see here that there was, this is caused by the changes that we did earlier. And then this is something that I not expect. So I have to refer the code. And now looks like it's still downloading the dependencies. Is there any questions? Okay, that's okay. Let's wait. Still building the image. Let's, if we want to see the log here, we can also do it from the Google Cloud Console. This is the log, so it's still building. Okay, so it's running now. So the image is being pushed now. So the logs that you are seeing right now on the workstation itself is actually similar with what we have in the Google Cloud Console. So it's actually building the image on the Google Cloud instead of local. And then, yeah, so the build is success. Now, what you can see here is that we start the deployment to Kubernetes cluster. As you can see here, the Kubernetes deployment is success, and it start port forward. So you can access the application now if you do it from localhost 8080. So if you do it this way, localhost 8080, you should be able to get a response directly from the application running in Kubernetes. How do I know that the application is actually running in Kubernetes? So let me show you something. So I will ensure you it is running in Kubernetes, but I still need to prove it. So let's go here. I will try to connect to Kubernetes cluster directly from the workstation. So I will run this command. So I will try to get the pods. So get pods. So you should be able to see that there is a pod running now in Kubernetes. And if you see here, there is a stream application log streaming, and the pod name is actually the same. So if you see here, the F9RG is pretty much the same with what we have in Kubernetes. And if we take a look into this log right now, so it is printing health check done. If I run it once again via localhost, I get response, and then I should be able to see there is another log being printed. So this is how Skaffold will help you. But that we are not going to stop there. What if I want to change something? So let's say I want to change the message returned by the health check itself, right? I will just change the response, health check feed to response here, and I will save it. Once I save it, Skaffold will retry, will redo the build, and then eventually redo the deployment with the latest image that it just built. So what we will expect next is that once we run curl again locally, we will see the response will be different. So let's wait again for the new image to be built. Meanwhile, if there is questions, please let me know. Is there any questions, or probably uh, people from the GDG team want to have some questions? Am I still connected, by the way?
I think you can check the question in chat box and state. No, state. Yes, there is a question. State.
Stage.
Yeah.
I see. Okay, cool. Yeah, there is a question from Kin. Chris. Chris here. I'm pretty new in this cloud deployment. Can I ask which platform is the best place to learn Scaffold and Kubernetes? So I think for Kubernetes, you can go to Kubernetes documentation itself. So I think it's very good resources to learn. There are also some tutorials that you can follow. For Scaffold, I think you can go directly to the Scaffold documentation itself. So once you are used to with all of the terminologies provided by Kubernetes, like deployment, pod, services, and so on, it will be easier for you to grasp concept from Scaffold. So actually, Scaffold is just a CLI that you can use to deploy your code to Kubernetes. But yeah, I think the best place to learn is from the product documentation itself. So actually, Google, because Scaffold is created by Google, so there are a lot of documentation in Google website as well regarding Scaffold. But I think the best way to learn, to explore what capabilities Scaffold and Kubernetes has is from the documentation. Okay, thank you, Chris, for asking. Let's go. So yeah, we are still, yeah, so the deployment is done. So now, if we run curl again, So we should be able to see that the response now is changed. So as you can see here, right, there is no git commit, git push command being executed. Everything that we did is just running Skaffold CLI by using Google Cloud Code. And in this case, we should now, as you can see here, we should be able to do direct deployment to Kubernetes without doing it by CI/CD. So all of the problems that I mentioned earlier, like this one, we are not running the same production and we are not running the similar environment like production. So this is solved now because currently we are running on the Kubernetes itself, which is the exact platform that we are using in production. And it is hard to get enough feedback. No, because we can see the log as well. And it is fast, it is quicker than following CI/CD pipeline. So there is no CI/CD things executed anymore. We are just doing it from local. So it is much faster. And actually, unfortunately, because we are not able to do to demonstrate the debugging process, so I I can really show it to you. But if we explore later, I have video in my YouTube channel where I successfully do debugging in Kubernetes from my local computer. So you probably want to take a look. So yeah, I think this will be solved as well if you are using Scaffold, because when you're using Scaffold, right, what we can do is that we will just run this one. So as you can see here, there are several issues with the configuration itself, which I'm not aware of, and I don't really can just run this command, and then what you can do next is just set the breakpoint. So when you execute it, you will be able to see there is a breakpoint, or the code will be stopped on the breakpoint you set. So that's how you're gonna do live debugging in Scaffold. So yeah, that's pretty much that I want to tell in this occasion. So I think, yeah, if there is more questions, I will be happy to answer that while we still have time. Yeah, thank you so much. If you want to reach me out later after this event, feel free to reach me out via Twitter or my YouTube channel. That's it. Thank you. Is there any other questions? Yeah. There is a questions, I think, from Chris again. I believe GoTo Financial is the parent company of Gojek. Yep. It's Go. No, no, no. It's GoTo Financial is sister company of Gojek. So the parent company itself is GoTo, and then under GoTo there will be several entities like GoTo Financial, which has a financial product like GoPay, our e-wallet system, and there will be several financial product as well, like lending and that kind of thing. And there is also Gojek, our ride-hailing app, and also Tokopedia, the e-commerce that we recently merged with. And then, what kind of tech stack are mostly used in your company? I'm currently working on GoTo Financial, where we are managing the payment system, which is the GoPay app. Currently, we are using GCP and AWS. We are not using Azure. So yeah, mainly all of our application are running now 100% in containers. So all of our services running as a microservices in Kubernetes. And yeah, we are using a typical SQL database like Postgres, cache like Redis and MongoDB, and some kind of stateful component system. Yeah, so yeah, that's pretty much. Thank you for asking, Chris. Is there any other questions? I will be happy to answer that if any. It doesn't have to. I think if you don't have questions regarding my talk, I think feel free to ask anything about cloud technology, specifically in serverless or probably Kubernetes or container development. Very insightful session. Thank you, Chris. I really appreciate it. Okay, If there is no more question, I think we can conclude. Thank you so much, everyone, for coming to this session. So yeah, hopefully this will be useful for you. Uh, and hopefully you probably can tell your colleague or probably your lead to consider using this kind of technology because it will help you improve your development productivity. I think yeah. Thank you so much for joining. Yeah, that's it. I will return it back to the moderator. Thank you so much.